Okay, hi everyone. Today we're going to look at two figures, a rhombus or rhombi and squares. Alright, so we looked at rectangles before. These are similar figures. They've got some similar qualities for some of them, and hopefully they make some sense as we go. So a rhombus is a parallelogram with all four sides congruent. Now you guys may have heard of a square, just back in elementary school, having all four sides congruent. That's true. But a rhombus has four sides congruent, and notice it says nothing about the angles. Okay, so this figure right here is a rhombus, and it looks kind of like a diamond, and that's what I hear a lot in some of my classes. It looks like a diamond, and that's right. Okay, that's the traditional diamond that you guys are used to seeing. But all four sides are congruent. Now, here's a couple theorems that come into play with rhombi. If the parallelogram is a rhombus, okay, which we're saying it is, the diagonals are perpendicular. Now think about what the word perpendicular means. It means they meet at a right angle. So all of your diagonals will meet at a right angle in these rhombus. Okay? Now the second thing, if a parallelogram is a rhombus, each diagonal bisects the pair of opposite angles. Now we've talked about bisecting before, but basically what that says is it cuts these in half. So if you look here, I've got this angle 1 and 2. What that means is angle 1 is congruent to angle 2. Okay, down here, angle 3 is congruent to angle 4. Okay, angle 5 is congruent to angle 6. Angle 7 being congruent to angle 8. Okay, and all that is true because this is a rhombus. Okay, so this thing bisects its angles on the opposite sides. Alright, so let's see, based on what we have, if we can solve a problem or two. So if the diagonals of the rhombus intersect at K, so I've got this rhombus here, it says it intersects at K, use the information to find each unknown measure. Alright, so we've got FJH is 82 degrees, so this large value right here is 82 degrees. I want to know what is KHJ. So think of where KHJ is. So KHJ is right there. Well, how can that help us? Well, it starts with the definition of a rhombus. A rhombus is a parallelogram. And if you think about what we knew about parallelograms, the consecutive angles, okay, so think this angle and this angle, add up to what? Well, they're supplementary, so they add up to 180. So if this is 82, that means that this larger angle right here has to be 98 degrees. Okay, now that's the large angle. That is GHJ. Okay, so this is angle GHJ. Well, we don't want GHJ, we want KHJ, and that's just the smaller angle. Well, the theorem we looked at before said that the angles of a rhombus were bisected by the diagonals. So that means I'm going to take this angle here and basically cut it in half. So KHJ is going to be half of 98, which is going to be 49 degrees, and there's your solution. Alright, so we got to go back and think of some of the properties of parallelograms, the fact that they bisect angles, the fact that the consecutive interiors add up to 180 helped us in this problem for the rhombi and the parallelogram. Alright, the second one. I'm going to erase this so we can kind of isolate and see what we're looking at. The second one here says GH, which is this side right here, is x plus 9. JH, which is this lower one here, is 5x minus 2. We need to figure out what is x. Well, this shape is a rhombus. Okay, a rhombus has all four sides congruent. And anytime things are congruent, they are equal. Okay, so that means that 5x minus 2 is equal to x plus 9. And now you solve. So subtract x, add 2. That gives me 4x equals 11. Divide by 4. And x is 11 fourths. Now make sure you're reading what the question says. If it says what is GH, you have to substitute back in. If it says what is JH, you have to substitute back in. Alright, so that's using those properties of the rhombus. Okay, let's move on. A square. Now, a square is a parallelogram. Opposite sides are parallel. Opposite sides are congruent. It has four congruent sides, which is a rhombus, but it also has four right angles, which is a rectangle. So a square is technically a rectangle and a rhombus. Okay, so it's both a rectangle and a rhombus. Alright, so let's look at this. Few theorems that come out of this. Here we go. If diagonals of a parallelogram are perpendicular, the parallelogram is a rhombus. Okay, so they give you a parallelogram, they tell you they're perpendicular, that means it's a rhombus. If one diagonal bisects a pair of opposite angles, it's a rhombus. Now these are two things we've already seen, just basically the converse, or we're flipping those things around. If one pair of consecutive sides of a parallelogram are congruent, it is a rhombus. Now I want to explain this one. Here's a parallelogram. Consecutive sides mean the two sides next to each other. So they're saying those two are congruent. Now, they've already told you this is a parallelogram, so opposite sides are congruent, so these two are congruent. That means that these two are congruent because they're opposite sides as well. Now all four are, that is the definition of a rhombus, so that's what it means there. Consecutive sides are congruent. And then finally, if a quadrilateral is both a rectangle, all your angles are 90 degrees, and a rhombus, all the sides are congruent, then it's a square. And that's more or less the definition of what the square is. Alright, final thing for this section. We want to write this two-column proof. Okay, here we go. It says QRST is a parallelogram, which we see. Okay, we have TR congruent to QS, and QPR is 90 degrees. We need to prove that it's a square. Well, with any two-column proof, we start with the given. So we go QRST is a parallelogram, TR congruent to QS, and QPR equals 90 degrees. And that's all just given. Alright, so I want to look at this and I want to mark this up. So TR is my diagonal, it's congruent to QS, so basically this whole diagonal is congruent to that whole diagonal, and then QPR is 90 degrees. That angle right there is 90 degrees. That's what we know. Okay, let's see what we can do. Well, here's what we can think. Because these two, because the diagonals create a 90-degree angle, QRST is a rectangle. Okay, and the reason is diagonals are 90 degrees. Okay, we knew that. All right. Since QS is perpendicular to TR, okay, so QS is perpendicular to TR, and all that is the definition of perpendiculars, okay, because there's a right angle there. We can also say that QRST is a rhombus. It's a rhombus. And based on one of the theorems we just looked at, if the diagonals are perpendicular, it is a rhombus. Alright, so right here we've said that QRST is a rectangle. And we said it's a rectangle because the diagonals are congruent. Okay? We've also said that it's a rhombus because the diagonals are perpendicular. Well, that tells me that QRST is a square because it is both a rectangle and a rhombus, and that is one of our theorems that we had up above, and there's your proof. Okay? Now I want to go back. I made a slight mistake right here. It's not that diagonals are 90 degrees, it's the diagonals are congruent. That's why it's a rectangle. I apologize. Okay, so it's a rectangle because the diagonals are congruent. It's a rhombus because the diagonals are perpendicular. It's a square because we have proven it is a rectangle and a rhombus. Alright, if you need some help, contact me online. Otherwise, good luck on your assignment. Let me know if you have any questions.